Here we'll dive into how to use a voltmeter or ammeter. And we'll start with the voltmeter. And the voltmeter measures the potential difference, delta V, between 2 points, and therefore we need to connect it across the region of interest. Now often the region, what I'm calling the region of interest, is really just one element. Like you might be measuring the voltage across one resistor or one EMF. But sometimes you actually want to go across many different things between 2 different points on the circuit. And that's why I'm saying in general we connect it across whichever region that we happen to be interested in. So as a simple example, to measure the voltage across the resistor, given this extremely simple circuit, we connect one side of the voltmeter at point A and the other lead to the voltmeter at point B. And then the voltmeter will actually represent, or it will show us, the voltage between points A and B. And since we chose A and B on either side of the resistor, that means that it's also equal to the voltage across the resistor. Okay, here's an example of how you would use the voltmeter. And so I have this electric circuit, and it's built with this kit called snap circuits. And basically there are wires that connect together. The EMF in this case is this pair of AA batteries, which add up to about 3 volts. And the resistor that I'm using down here is a 100 ohm resistor. So, and I don't have a dedicated voltmeter, instead I have a multimeter. So I turn the multimeter on, and I'm setting it to, it's not an auto ranging multimeter, so I have to set the range, but it's set to show a number between 0 and 20 volts. If I want to measure the voltage across the resistor, then I have to actually connect the leads to the metal parts of the resistor, and I can see that there's a voltage of 2.74 volts across the resistor. If I measure the voltage across 2 points on the same wire, and when I snap these all together, they effectively become one long wire, I get 0 volts. If I measure the voltage the other way, now notice I have a black lead and a red lead. If I switch those and then measure the other way, I get negative 2.7 volts, or 2.73 in this case. So when you're using the voltmeter, you have to pay attention to which side is positive and negative, and then the negative reading on the voltmeter just indicates that you might have connected it backwards, or maybe the voltage is opposite what you were expecting. The other instrument that you'll be using a lot during labs is the ammeter, and the ammeter measures current through a wire, and therefore we have to connect the ammeter so that all of the current in the wire goes through the ammeter and then continues on through the rest of the circuit. And if we had the same circuit with an EMF and the resistor, and we want to measure the current through the resistor, then we would initially start out with the circuit as shown and the ammeter near the circuit. We actually have to break the wire. Now this doesn't mean you have to cut the wire, but we have to open up the connection somehow. So what we do then is we quote-unquote break the wire at that point that I'm showing in green, and then connect the 2 leads of the ammeter to either side of the broken wire. And then all of the current that goes from the EMF through the resistor then has to go through the ammeter from the red side to the blue side and then back to the other side of the EMF. To use the ammeter to measure the current through the resistor, remember that I first need to disconnect the circuit. So I want to make sure that all of the current that flows through the resistor ends up going through the ammeter before it continues in the circuit. And right now this is set for DC volts, so it's measuring up to 20 DC volts, and I need to change the setting on my multimeter as well. It turns out it's in the opposite setting, and I'm setting it to the 200 milliamp range because I did some testing a few minutes ago and realized that it was about 20-something milliamps. Then I connect the red lead to one side and the black lead to the other side, and lo and behold, I'm getting about 25 milliamps of current going through this circuit. Now as soon as I take it off, the current stops flowing because it can't go through the circuit. It actually needs to go through the red wire, through the ammeter, and then through the black wire to continue on in the circuit. Now, if I accidentally connect the ammeter backwards, if I'm measuring closer to the resistor with the black lead and further with the red lead, I still get a result, but instead of having a positive current, I'm having trouble holding it on here. Often you can get clips, and I think I have some clips that would have been easier to use, but anyway, in this case, this is what I have. So in this case then, when I connect it in the opposite way, with the black lead towards the resistor and the red lead towards the bottom of the EMF of the batteries, then I get a negative current flowing through. So what this tells me, and it's worth testing this out in the lab, because there's nothing that beats hands-on experience, but also you want to understand how this works. And sometimes there are questions and even physics problems on exams where they show you that an ammeter was connected and it gives a certain reading, and they show you the positive side. And you need to use that information to help you figure out what direction the current is flowing. So for this ammeter, when I have the red lead connected towards the resistor, I get positive current. So that shows that the current is going positive from red to black.